solve the following equations, and these both involve absolute values. So what we need to recall is that if we had something like the absolute value of x is equal to n, where n is positive, then x is equal to negative n, or x is equal to positive n. So if we have the equation absolute value of x plus 7 is equal to 4, then that tells me that x plus 7 is equal to negative 4, or x plus 7 is equal to positive 4. Solving these equations are relatively easy. I would subtract the 7 from both sides here, and so x would equal negative 11. Subtracting the 7 from both sides here, x would equal negative 3. So there are two solutions to the equation, and we could easily check them by substituting back into the original statement. Now, exercise B has a slightly more complicated equation. 2 times the absolute value of x minus 5 plus 6 is equal to 20. What I'm going to do is I'm going to solve for the quantity in absolute value, and then I'll use the fact that I stated earlier. So the first thing I'm going to do is subtract 6 from both sides. Twice the absolute value of x minus 5 is equal to 14. Then I will divide both sides of the equation by 2, and so I have the absolute value of x minus 5 is equal to 7. Now, using the fact that I stated earlier, x minus 5 would equal negative 7, or x minus 5 would equal positive 7. Adding 5 to both sides of the first equation would give me x equals negative 2. Adding 5 to both sides of the second equation would give me x equals 12. So again, two solutions to the equation. Absolute value of m minus 4 plus 12 is equal to 8. Again, I'll isolate the absolute value quantity. So I'll subtract 12 from both sides. The absolute value of m minus 4 would equal negative 4. Now, when we have a situation like this, where we have the absolute value of a quantity equaling a negative number, this equation has no solutions. I should say no real solutions. Right? The absolute value of x cannot be a negative number.